Hey, what's up guys? I always get this question, what is sine? I look online and I see a lot of, oh, it's the side over the hypotenuse. It doesn't make a lot of sense to me, so I thought I'd do my best to try to explain it. Basically, to make sense of like what sine really does. So, here's the idea. If I give you some triangle, one condition, it has to be a right triangle. You tell me what this angle is. You say, all right, this angle has to be 30 degrees. And you give me this side. Doesn't really matter, we'll talk about this side for now. And you say, all right, this side has to be 5. Well, guess what? If this is 30, and this is 5, and this is a right triangle, this has to be 10. Has to be. Because the 30 degrees, and this is 5, has to be 10. True in every single 30-degree triangle, or that's 5. So really what you've discovered is that, oh, if I give you a 30-degree triangle, in a 30-degree triangle, the ratio of the opposite side from that 30-degree angle over the hypotenuse equals 5 over 10, which is 1/2. So what happens if I take another 30-degree triangle and just make it a little bit bigger? Say, all right, I still want that side to be 30 degrees, but now I want to deal with a bigger triangle. Let's say that this side is, I don't know, 8 now. So this side is 8, this is 30 degrees. Again, you gave me this, you gave me this. This side, the hypotenuse, is locked in at a certain length. It has to be 16. Has to be. If you try to construct this triangle with these actual physical measurements, again, you choose this to be 8, this is 30, has to be 16. So, again, in this other 30-degree triangle, where you have the ratio of the opposite side of the hypotenuse, 8 over 16 also equals 1/2. In every 30-degree triangle, if you give me one side, the hypotenuse is always going to be, and this for 30-degree triangles, double this opposite leg length. The ratio in every 30-degree triangle of an opposite side to the hypotenuse is always 1/2. So someone came along and said, if that ratio is constant in 30-degree triangles, I'm going to invent this function called the sine function, and we ignore the E when we abbreviate it, and I'm going to realize that the sine of a 30-degree triangle, which is this relationship, equals 1/2. I plug 30 degrees into the sine function, it gives me the ratio of that opposite side to the hypotenuse. And that works for every triangle. Sine is that ratio, it's that relationship. So I could give you something like, okay, sine of a 57-degree triangle. Sine of a 57-degree triangle. And if you have a calculator, you can pull it up, you can take a look. My calculator's dead. You can type in sine of a 57-degree triangle. I did it on my computer because I'm recording. Sine of 57 is 0.43, which means the ratio of the opposite side to the hypotenuse in a 57-degree right triangle is 0.43. That's the ratio. So you give me the sine of any angle, you plug in any angle, bam, I'm going to give you the relationship between that opposite side and the hypotenuse. And that's kind of how the trig functions work. You plug something in, you get something out. You plug in the angle, you get that relationship between the opposite side and the hypotenuse. It's a function. Hopefully this helped a little bit. Thanks for watching.